All right, so security. So what we're going to do is we're going to talk just loosely about the shared responsibility model, which says, what are you responsible for? What is AWS responsible for? We're going to talk about a little bit IAM, which is just basically it's usernames and passwords. It's users, it's groups, and this funky thing called roles, which if you know about sudo or the Windows Administrative Elevation, you're familiar with roles because it gives you temporary elevated security permissions. We're also just going to mention the word organizations, which is a way to create multi-account, like multiple AWS account structures. So like, for example, I walked into a company that had 700 accounts and they were managing them all separately. If you put them into an organization, you can manage them all at the same time. Kind of. There are limits to that. And then we're going to go through a couple of extra AWS security services, but I'm just going to mention them in passing. We're not even going to deep dive on them because there's a lot of them. Okay. Let's talk about shared responsibility first. So first, here's the deal. We are responsible for the security of the stuff we stick in the cloud and the services that we launch, but only if we have control over them. In other words, if you launch a serverless service, you don't have to patch the operating system because you can't even see the operating system because to you, it's serverless. Not to Amazon, but to you. Everything else when it comes to Amazon's physical data center, securing their networking, securing the hypervisor that hosts all the virtual machines, protecting network traffic so that everybody can't see everybody else's traffic, patching operating systems in a serverless environment, that is all AWS. They're responsible for that. You can think of this model being the division between a home builder and a homeowner, except Amazon kind of owns a portion of the home, so it's a little bit even more involved. So we're responsible for security in the cloud. AWS is responsible for the security of the cloud, meaning if you can log into it and you can configure it, then you're responsible for it. If you can't log into it and you can't configure it and you don't even know physically where it's located, you can't defend it. You're not responsible for the security of it. So remember, you have responsibility for stuff you can configure. AWS has responsibility for pretty much everything else. Now let's test your knowledge there of that statement I just made. If you're configuring security groups on Amazon EC2, which security groups are firewalls, who's responsible for the results of that configuration? Is it you or is it AWS? Is it customers or is it AWS? Not necessarily you, right? That's right, it's customer. All right, who's responsible for maintaining the network infrastructure underneath all these virtual machines? Who does that? Yeah, AWS is the primary owner of that. Who's responsible for implementing physical security controls at the AWS data centers? Who is responsible for that? Good. That's right. Who's responsible for patching software on Amazon EC2 instances? Well, John, that's a good point, but just so you know, all EC2 instance launches by you are infrastructure as a service, right? Because you can log into the operating system. So what would be the answer if you can log into the operating system that you launched? Yeah, yeah. If you can't log into the operating system, you're definitely not responsible, but every EC2 instance you launch, you can actually log into the OS. Maintaining the host hardware that runs the Amazon EC2 instances, is that AWS or is that customers? Excellent, good. And then setting permissions on your Amazon S3 objects, including whether someone has public access to your bucket or not. People show up in the news, they're like, how come Amazon It's so bad at securing their S3 buckets. It's like, because Amazon's not responsible for securing your S3 buckets. The customer is. Okay. That was all just the shared responsibility model. Let's talk about IAM next. Now, IAM is identity access management, and here's the deal. If we have a new cashier starting in our coffee shop and we want to give them access to the point of sale system, we gotta put them in a username and password or some kind of code or something that identifies them, right? Now, IAM allows you basically to manage the access to AWS services and resources. So this only is used to give access to AWS resources. There's only 3 principles, by the way. There's the IAM user, the IAM group, and the IAM role. Each of those can have a policy, a permissions policy attached to it that will allow you to get access or deny access to services. Now, I say that there's a 4th entity that exists outside of IAM, and that's the person who created the AWS account. That username is usually an email. I say usually, it's always an email, because Amazon requires you to have a unique email address per account. So when you create an account, it requires an email address to make that happen. The first thing you do once you log in using the root owner username and password is you create an IAM user, and then you lose the root account. Just lose it. You can reset the password easily, but just like set it aside, right? Save the password, put it away somewhere. Don't use the root login to log into your account. The reason is, by the way, if someone cracks that, and you can't put limits on it, so just set it aside. You can put on 2-factor and other like security policies if you want to. But once you create your first IAM user, log back in as that user and use that user to grant yourself permissions, right? Or better yet, create a security role for that permission that requires it to elevate to the role before it has admin rights. Even better. So users are the core entity that are used inside of IAM, and they represent users. There's a one-to-one association. Sometimes they can represent applications that are outside of AWS's ecosystem of infrastructure, but typically they represent users. Now, these user entities, like a username, can actually have policies attached to them. The policies look like this. This particular policy, if you just let your eyes scan down to where it says effect, this policy is allowing something to happen. In particular, it's allowing you to either list or get objects inside of an S3 bucket. And notice that is there a very specific bucket listed under resource. It's example bucket, right? Notice that it's saying that you can do the get object and list object against the bucket and the contents of the bucket. So just know that you actually have to have permissions to both for this to work. That's just an S3 kind of caveat. In addition to having users that can have permissions attached to them. Yeah, so John, to answer your question, yeah, so the default effect is an implicit deny. So by default, if you don't give anybody permissions, they can do nothing. If you give someone allow permissions, they can do something. If you go in and explicitly deny someone access to something, they can never get access to that system until you remove the explicit deny. Explicit denies trump everything. So other than users, there's also groups, which are just collections of users. You can attach policies to groups as well. That's the recommended method. Please follow the principle of least privilege and give someone the bare minimum they need to do their jobs. That's it. Just give them the barest minimum. And then last but not least is that you might want to give someone the ability to escalate to like manage EC2 instances for their project, but you don't want them to sit with those permissions all the time. This is no different than using sudo if you're familiar with Linux administration, where you have to do a sudo and then a command in order to get elevated permissions. What happens here is that this allows you to assume a different set of permissions, but your core identity doesn't change. me show you what this looks like, because this would be an interesting thing to see. So right now you can see that I am listed as Spartan Sage in the upper right-hand side. Right, I'm Spartan Sage. If I come over here and say I want to switch to a different role, first I'm going to put my account number in. By the way, note that I could switch to a role in another account if that role gave me permissions for my account and username to access that role. So this is all permission based. You can't just assume another role. The role has to give you permissions to assume it. So in this case, I'm going to assume Enforcer admin, and then note what happens in the upper right hand side. I'm now an admin actually in my account. That's because I assumed the Enforcer admin role. So just know that this allows you to keep users like in kind of a read-only space until they need to do something, so someone can't accidentally delete something that they shouldn't or doesn't belong to them. So something to keep in mind. So in this particular case, in our coffee shop case, we can actually give our users read-only access to the point of sale system, but then give them a cashier role when they need to process something, so they can access the cash register to do something that normally wouldn't have permissions to do. This could be the same for inventory as well. They could assume the inventory role when they're doing inventory. That way they don't actually do something to something else. As a general rule of thumb, and everyone should take this in for me, AWS wants you to think of roles as a way to grant temporary access to permissions. They don't want you to think of roles as a permanent solution. Now they say that. I also want to mention that people use roles all the time to grant services access to other services. So roles are how you, for example, give an EC2 instance access to DynamoDB. And by the way, if there's an application running on that instance, it now has access to DynamoDB because the environment it's running in now has access to DynamoDB. Hope you're following me. Last but not least is MFA, or two-factor authentication. All of us should be using it. You saw me use it earlier when I was logging into my system. So just know that multi-factor, two-factor authentication is basically necessary. So something that you know, and now you're looking at something that you have. John, this isn't conditional access. No, you can actually set conditions on any policy at any entity that you want to. For example, you could put a condition on the policy that says, hey, this role has access to the cashier role, but only if they're inside the store. Like only coming from this IP range, or they only work on Sundays, so they can only do it on Sundays, or they have to use encryption. So conditions can be set for any of the entities. That's a conditional section that's inside this policy right here. And there's no condition section here, but you can set conditions. By the way, conditions are what make this thing work, because it's amazing what you can do with conditions. Most of my policies say that you can only access my stuff from my IP address here at my house, which is static and doesn't change. Although I'm assuming one day it will. All right, so that's all IAM. IAM is the service that grants and controls access to AWS resources for your account. IAM is a global service, so it works the world over and it costs you nothing. And by the way, you can federate IAM with Active Directory, Okta, Ping Federated, ForgeRock. You can federate with anybody who supports OIDC or SAML. So you don't feel like you're just locked into using IAM alone. You can actually use it with other things. Okay, so I may have mentioned this earlier, is that when you want to manage a large collection of accounts, so like you might have a bunch of IAM services in a bunch of accounts, right? How do you manage users at scale? Now, I'm going to forewarn you is that organizations doesn't really let you manage each individual account down to a granular level. You still have to use IAM in the account for it. But if you need to go in and say, look, nobody in the entire company can use quantum computing because that's not our business model, that's what organizations is for. Organizations lets you consolidate and manage multiple AWS accounts under the same umbrella. This includes billing, compliance and control, auditing, enforcement as well. So it allows you to control permissions for your entire organization. Now, the way this works is that you can apply what's called service control policies to place restrictions on the services, resources, and even individual API actions that users and roles in each of the sub accounts can actually do. Now, you can do this over the entire organization. You can apply an SCP to an individual account, or you can apply it to what's called an organizational unit. So here they're applying policies from the root, and they're going to trickle down to the account. Here, someone has created what's called an organizational unit. Let's call it production. And that production, or in this case, it's legal and HR. So let's say corporate. It's a corporate organizational unit. That organizational unit might have a completely different set of permissions of things it can access than finance and IT. So SCP, service control policies, are what are established. The other benefit to this, though, is that if all 4 of these accounts are using S3, what will happen is that when you get billed in the root account, it's going to aggregate all that usage together, and it's going to give you a cheaper price per gigabyte, which is cool, actually. I once saved a company $7 million just like that by putting everything into an organization, not adding any service control policies, and consolidated billing activated, and they instantly saved that much money in their S3 buckets. Now, don't ask me how much they were spending per month already, but you could probably imagine it was already tens of millions. Okay. So a customer is configuring some of these service control policies that I was just talking about. What identities or resources can SCPs be applied to inside of an organization? And this question is trying to tee you up because some of these answers belong to IAM and some of them belong to organizations. No? It's definitely C and E. So C and E is individual member accounts, and E is an organizational unit. By the way, you can also just apply it at the root level, so there's actually a third option. Good. Thank you, Delaney. Okay, so let's talk about compliance. So Amazon has a ridiculous number of certifications. If you want proof, every single AWS account has a service called Artifact, which contains a copy of all of Amazon's ISO 27001 certifications, all of their FedRAMP certifications, all their PCI DSS certifications. They're all of these are inside of this. So if you need to find something related to AWS's status, you're either going to type in AWS Compliance Center inside of Google, or you're going to go to AWS Artifact inside your account. And you're going to get access to all the certifications that make this real. There is a Customer Compliance Center. You can literally just type that into Google and it will take you there. Basically, it contains white papers, checklists, everything that you want to help give you access to technical documentation, how to do auditing. I've been through 3 audits with AWS in the last 5 years. They are a good partner, and auditors are very familiar with them. So just also to show you this is if we go to AWS Artifacts, first of all, there's two things you can do inside of Artifact. You can view all the security reports. So if you're looking for a PCI, for example, here it is. So you can get all those, the attestations and certifications. The other thing you can do is if you have an enterprise agreement with Amazon, you can see it here. Now here's a data breach addendum, but if you had you signed a contract with them, it would show up here as well. So you can actually sign agreements inside of Artifact with Amazon as well. So it's pretty cool. Knowledge check. Which of these 5 tasks can you complete in AWS Artifact? Take a look and let me know. All right. C and E. Well, so create users to allow people and applications to interact with AWS services and resources. Oh, wait, sorry, Delaney, I'm reading you from the last one. You posted that like 3 minutes ago. Sorry. So the answer here is A and E, as posted by Darren and John, is that which task can you complete in AWS Artifact? You can complete the compliance reports, like you can view those. You can also review, accept, and manage agreements with AWS. So that would be the kind of agreement section. All right. Questions about AWS Artifact or, well, really any of those pieces? All right, so let's talk a little bit about protecting layer 7, protecting application security, not infrastructure security, although it can have some, obviously that has implications there as well. So let's talk about if you need to prevent people from maliciously injecting like cross-site scripting or SQL injection attacks or that kind of thing. Amazon has a product called WAF, which is a web application firewall. It's a layer 7 firewall that goes in front of your application, in front of your load balancer, and its job is to protect malicious, like prevent legitimate traffic from being blocked. Like it allows that in, but it blocks malicious traffic. This comes off of a list of rules that you can actually either pre-buy from the marketplace or you can make your own. So if there's a malicious request, it would block it. Now, a denial of service attack is when someone's trying to attack you from a single source. A distributed is when there's like thousands, if not millions of sources. Amazon does have a service that will help with this. It's on by default on every account for free. It's called AWS Shield. There's also a paid version called Shield Advanced, and it will integrate with a bunch of other services, including writing custom WAF rules to block an attack while it's happening. So just know that Shield is the distributed denial of service kind of blocker, and there's a paid for version that will help you do it even better. Now, Inspector is a vulnerability assessment tool that comes with AWS. It does, there's a cost to it, right? But it basically checks both the network and the host operating system, like from vulnerabilities. So it checks your network of it, like pen tests your network as well, and it checks for vulnerabilities, known CVEs inside of your operating system. Here's a few other security services to just kind of put into your brain. First, there's the key management service, which helps you encrypt data at rest. So disks, right? In some cases, it's actually used for data stores as well, right? Then there's guard duty. Guard duty is a cool little tool that uses machine learning to check for malicious network probes and malicious network attacks against your VPC. This is a cool little product because it checks the VPC flow logs and the DNS logs from your local system to find out if you've been hacked or if someone's trying to hack you. So if it detects any threats, it's going to send a notification right away. You can also set it to auto remediate and block known threat actors. Here's a little knowledge check. What describes, what is the purpose of an IAM policy? What does it do? What is it? So an IAM policy is a document that grants or denies permissions to AWS services. The first one, an authentication process that provides you an extra layer of protection for your AWS account. That's probably two-factor that they're referring to. C is an identity that you can assume to gain temporary access to permissions. That's a role. That's an IAM role. And then the identity that is established when you first create an account, that's called the root user. Nothing to do with IAM. An employee requires temporary access to create several S3 buckets. Which option should be used for this task? Hopefully I said this enough so you got it. Good. It is indeed an IAM role. Which option describes the concept of least privilege? It is indeed B, right? Granting only the permissions that are needed to perform the specific task. That's accurate. Which service helps protect your applications against distributed denial of service attacks? Which one of these did we say was the DDoS protector? Good. That one seems to stand out. AWS Shield and Shield Advanced. That's good. Which task can AWS Key Management Services perform? What does the KMS system have to do with encrypting and decrypting drives? What is it using to do that with? Good. So it is truly about creating cryptographic keys so that you can actually manage data at rest. If you encrypt it and decrypt it, that's what it's all about. Okay. So what we did is we talked about the shared responsibility model. So security of the cloud and security in the cloud, right? Of which we have in the cloud, they have of the cloud. We talked about IAM with its users, its groups, and its roles and its access policies. We talked about organizations, which uses SCPs to restrict based on either individual account, organizational unit, or just the overall like organization itself. We talked a little bit about WAF and Shield and Inspector, which WAF is a web application firewall. Shield is a distributed denial of service protection system. And Inspector is a vulnerability assessment system that looks for known CVEs. And then we talked about Artifact, which is used for compliance, as well as a bevy of these services at the end, right? Talking about guard duty, and the key management system. Okay. So that's the end of this module. Any questions about security?